my name is Justin Moyer. I'm a materials science engineering student going into my junior year. I am participating in the SURE program doing research in the Thornton lab. One great experience I had with the SURE program was being able to work with graduate students. It was very nice to have technical conversations with those at such a high level and be able to fully comprehend what they were saying and throw in my own input. The Thornton lab uses computer simulations to determine a number of different projects. My specific project deals with solid oxide fuel cells. These fuel cells are made up of 3 different materials: nickel, por, and a yttrium stabilized zirconia, also known as YSZ. As the fuel cell operates, it is a thermodynamic tendency for the nickel particles to try and coagulate in a process known as coarsening. My project deals with monitoring the coarsening of various structures and seeing how they evolve when run through a simulation. The nickel and YSZ electrolyte make a complementary pair to transport both electrons and ions. These mobile charges allow the anode to power a load. My main goal is to select features within my structure that optimize electrochemical properties and are most resistant to coarsening. I developed several structures and monitored their evolution through the simulation to help determine which characteristics were useful and which were detrimental. Some of the factors I varied throughout my research include the length between iterations, also known as the time step, the number of iterations, the length of the boundary between phases, the volume fraction of each element, and the shape of nickel and por features within the YSZ. Through my research with the SURE program, I learned about several potential career paths and fields that are of high interest to me. I have always been interested in alternative energy, so getting an opportunity to do research in this cutting-edge field was a wonderful experience. Though I ran many simulations this summer, there are a few things I feel should be investigated further. Structures that had a long 3-phase boundary were observed to be more stable. I feel more structures need to be developed to take advantage of the TPB stabilizing effect. These simulations I ran were generally under a minute real time, which is far shorter than the life of a fuel cell. Structures need to be run for time periods close to that of a fuel cell lifetime. The most stable structure I observed was an alternating nickel-por lamellar sandwiched between YSZ. This structure showed good electrochemical properties and was resistant to coarsening, so more tests should be done to optimize that structure. I would like to say thank you to Professor Thornton for helping me choose and execute a project, as well as Shunyi Chen for his mentorship and guidance throughout. The SURE program was a wonderful experience for me, and the program staff was very helpful. Thank you for listening, and as always, go blue.